All right, welcome everyone to this Passive House Components Spotlight with Glavel Foam Glass Gravel. We're very happy that you all are here. And I think a lot of us have been eagerly awaiting the day when we can tour this awesome facility and learn more about foam glass gravel. So we're looking forward to that virtual experience today. My name is Zach Semke, and I'm director of Passive House Accelerator, and I'm very happy that you all have joined us today. We also, I want to remind everybody, have a fantastic Passive House podcast episode that we recorded several months ago with Rob Conboy, the CEO of Glavel. So if you go to our podcast page, you can find that there as well. Right. So we are so excited to have this presentation from the team at Glavel. And there is a team that's going to be presenting. I'm going to introduce just a couple of the team members, and then we'll have more introductions interspersed throughout the presentation. Glavel is a Vermont-based company that specializes in manufacturing lightweight aggregate from recycled glass. Its technology will enable the construction industry to more cost-effectively insulate below slab and achieve substantial reductions in the building material embedded carbon. Glavel is one of the first supporters of Passive House Accelerator and is a founding sponsor. So big thanks to Glavel for that support. Ken Minkar, the COO, has a diverse background in manufacturing operations and engineering. As a senior leader at IBM Microelectronics and Keurig Green Mountain, he has driven facility and production startups, scaling, ramp, and expansion of new and mature products. He brings a focus on continuous improvement and optimization of product quality, cost, and throughput. Rob Conboy, CEO, has over 25 years of sales and strategic planning experience, all of which have been with highly entrepreneurial companies. For the past 10 years, Rob has focused on renewable energy startups, bringing leading edge technologies to market at Draker Laboratories as Chief Operating Officer and at Thermal Storage Solutions as VP of Finance and Marketing. Rob has a deep understanding of how to expedite the acceptance of new technologies and building practices. So with that, I'd like to hand it off to the Glavel team and can't wait to see.
Awesome. Great. So here we are. Before we get started and get into it, in addition to introducing Ken and Rob, we have a plant manager now. Her name's Alicia. She's just to my left, and we would love to take this opportunity to give her an introduction as well. So Alicia.
Hi, so I'm Alicia Borgo, and I'm the new Glavel plant manager for our Saxon Hill facility. I come from 18 years of chemical manufacturing industry. The facility has come such a long way since I began back in September. When I first started, there was still like dirt floors and no equipment, nothing. So far, it's been a super exciting journey for me. And now we have an almost fully functional, beautiful, state-of-the-art electric kiln just waiting to be powered up. I've spent much of my time so far creating our safety programs and preparing for our upcoming OSHA inspection. We are dedicated to promoting not only a physically safe and clean working environment, following all the OSHA guidelines, but also highly focused on the well-being of our associates and promoting social justice. Part of Glavel's vision for a culture of acceptance is what first drew me to this role. The social responsibility aspect of surrounding ourselves in new beginnings, gender equity, and a supportive community for all is at the core of how we're going to operate and be successful. In a world where divides continue to exist, we aim to be a progressive company that will work explicitly to eliminate all of those divisions within our walls and create a culture of family and acceptance. We're currently working with a local Vermont staffing agency called Working Fields, as well as the Dismiss Houses of Vermont, to employ formerly incarcerated individuals. In addition, we're working with the Vermont Works for Women, the Pride Center of Vermont, Vermont Technical College, and New Americans to encourage all colors, religious minorities, women, transgender, gender non-conforming people, basically all backgrounds, to take steps into being employed into our manufacturing trade industry. We're anticipating running the new facility with 12 associates, being 4 12-hour shifts, and each of those shifts consisting of a team lead and 2 operators. As a new facility, we're obviously our beginning days will be filled with determining how the product's going to flow throughout the facility. And majority of that work will be centered around product management, moving the products to our storage yard, kiln maintenance, where we'll have a focus on proactive upkeep as opposed to preventative as opposed to reactive. Thank you. And then fulfilling our orders, whether it's truckloads, containers, bags. Currently, we are at 67% of our roles filled, and we're still looking for 4 day shift operators. And we are all so excited to start this journey. And I really can't wait to bring this new Glavel production team together and develop a dynamic all of our own and to be productive and fun.
Awesome. Thank you, Alicia. So before we go into what is foam glass, I'll also introduce myself. My name is Tor Dvorak. I'm in sales and marketing here at Glavel. I've been here for about 2 years after graduating from the University of Vermont's Sustainable Innovation MBA program. And that's pretty much all there is to know about me. So without further ado, I can get us into what is foam glass. Zach got us nicely started with his introduction. But just to get the ball rolling even more, it is a lightweight aggregate that is derived entirely from recycled glass that is both thermally insulating and load bearing. So to produce foam glass, Ken's going to get more into it in our video that we have with our facility tour. But for a brief description, so you kind of have a bearing on it, we take recycled glass powder, mix it with a foaming agent, and bake it in a 42-meter kiln with a pretty tightly controlled thermal profile. During that heating, it expands and there's chemical physical reactions that cause it to expand about 4 times its original size. And then it leaves the kiln, and thermal stress from the cooling causes it to break into the pieces that you can see on the screen here. This is something that's been done in Europe for 20-some years at this point. Back in 2016, Rob was at the Passive House International Conference in Darmstadt, Germany. We've heard this one a couple of times. And he saw foam. He was introduced to foam glass and thought we need to be doing this in the United States. So he's been working at it in earnest for a few years now, and it's really becoming a reality at this point, which is great. This product can be used for a number of different construction verticals: residential and commercial sub-slab insulation, which is most commonly what you'd see in a passive house application, but also green roof, fill, and civil applications. So road beds, embankment stabilization, lightweight fill. Now, just to get a few more of the high-level attributes of the product, it's made from recycled glass. So that said, it still holds a lot of the physical properties of glass in that it's inert. There's no organic content in it, so there's no pest concern with it. Once it's sort of buried in a sub-slab insulation, there's no pest or termite or ants to be concerned about. Glass is also fire resistant, so there is no issue with it catching on fire, and it won't propagate any flames either. There's a video on the internet of EPS foam in a fire, and it absolutely just goes up in flames. Glavel would not propagate fires in the same way at all. And then one of the other really upfront attributes of Glavel is how lightweight it is. It's 9.8 pounds per cubic foot, which is it's what, a 17th the weight of traditional gravel by volume. It's so lightweight that it floats even. And that's usually a good way for people to understand just quite how lightweight it is. So the fact that it's this lightweight yet so thermally insulating and structural is pretty unrivaled in the construction industry. Couple other things: it's closed cell, so water will not run through it. It can act effectively as a traditional aggregate would on a job site as a drainage layer. And I believe that's all the physical characteristics we want to touch on here. Now, this is a bit more of the specifics of foam glass. You can see particle size is the third one down, pieces range. This has it at 1.25 to 2.5 inches. That'll depend on how our kiln cools the product. That will affect how the pieces break up. But we anticipate larger pieces to be about the size of a fist, smaller pieces to be a little bit smaller than that. Thermal conductivity is the next listed item. For just typical building terms, it's R1.7 per compacted inch. So a 12-inch Glavel installation will net you R20 insulation. The next notable piece is compressive strength, which at 10% deformation is 116 PSI, which is more than enough for most typical builds, residential and commercial. It's pretty rare for us to see a situation where the compressive strength is insufficient for a particular build. Next, let's look at the fact that it's resistant to freezing and thawing cycles, which means over time there's not going to be any bucking of material, which just yields more longer term construction. And the last thing to feature in this is the possible flatness of end area, in that Glavel, once compacted, can be flattened to plus or minus 1 inch over a square yard. So you're able to get a very uniform flat layer. We've had instances where people need it to like 1/8 of an inch or a 1/4 inch, in which case it's possible to do like a 3/8 stone pea gravel on top if you need to get like a hyper precise flatness. Now, this is a detail that we often use for individuals who are looking for sub-slab insulation, which, as I said, generally the passive house market is looking for. On the left here, you can see this is a traditional installation, traditional sub-slab insulation. You have 4 inches here of EPS foam, R5, and then below there's 8 inches of crushed stone aggregate gravel. Between this 12-inch installation, you have R20 R20 insulation. On the right here, we have a Glavel installation, which is the same 12 inches, but instead of having multiple trades, instead of having multiple products that need to be installed specifically, it's one product that's installed. And this compacted 12 inches also nets you the same R20. You can embed any sort of piping or plumbing within the layer as you see fit. The Glavel layer can be compacted on top of it. There's no sort of specific concerns in that regard. And then pipes here will also benefit from that marginal amount of thermal insulation that's found around in case there's any concern for thawing and freezing with pipes, which are not granted the thermal insulation from the stone on the left. And based on some numbers that we did a number of months ago, which I'm sure things have shifted around a little bit, our estimate for total installed cost per square foot on the left was $3.17 versus the Glavel, which would be $2.42. So it's time saving and versatility in addition to cost savings. Now, lastly, I've mentioned the product being compacted. Glavel is, when it's brought onto a job site, Glavel is, sort of dumped in as a traditional aggregate. It can be flattened with any sort of rake or any sort of material that or any sort of, what would you have? Yeah, a hand tamper. And then you'll run over it with a plate compactor, and you reduce it to a 1.3 to 1 ratio. And that creates the nice flat load-bearing stable base. This detail just showcases how to sort of do that calculation for quantity required, which this is sort of a complicated way of saying you take your volume and multiply it by 1.3 to 1. Now, we have to do a little Texas two-step here. I'm going to stop sharing And then I'm going to reshare.
Hi, I'm Ken Minkar, the Chief Operating Officer of Glavel. We're really excited to be here as part of the Passive House Component Spotlight Series. We're going to give you a quick introduction to our facility, a little virtual tour, and we'll start out here in the lot just outside the facility. We're standing here in the foothills of the Green Mountains, actually literally in the shadow of Saxon Hill, which is a prime mountain biking area, notable for Vermonters and other mountain bikers from far and wide. We found this facility last fall and have been working on fitting it up with our process and our equipment since midsummer. What you see behind me is the back of our building and the storage lot that we'll be using to put our finished goods. You can see the guys are over there kind of just putting finishing touches on the storage area. We're currently finishing about an acre of storage. When we're in full production, we will store product there prior to putting it in trucks and bags to be delivered to customers. The process will start over by this blue lift. When we get to full production later in 2022, we'll be receiving recycled glass in that bay where that lift is, and conveying it into the building where it'll be processed, cleaned, and milled into a fine glass powder. We're not starting at that stage with the recycled glass in its raw form. We'll actually be starting with purchased glass powder from a recycler in the area. And that powder will be delivered by differential pressure trucks to this silo, which we just put up about 6 weeks ago. So that's a 60-foot tall silo purchased from a supplier in Oklahoma. And that'll house about 240 tons of glass powder, which will serve with one production line about 11 days of production. So with that, maybe we can go inside and we'll look at the equipment. All right, so now we are inside the building, standing on the second tier of our mix and dose station platform. So this is a multi-tiered steel structure that rises to a ceiling height of about 30 feet. The purpose of this part of the process is to blend the glass powder with our foaming agent, which generates the gas when heated to create the foam. When we were outside, we were pointing at the silo. You can see that through the window at the end of the building. The powder is discharged through the bottom of the silo, goes up a pipe just inside the far wall, and runs across just below the beams of the ceiling here. That powder is called for by this mixer that we're standing next to. It runs in a series of batches, blending and then distributing the powder, the wetted powder, when needed. That powder is pulled by vacuum from the room downstairs and through the pipe behind us. Some keys about the process. The powder itself is actually pretty critical. We have to get the purity of the glass to a very refined state. We ensure that there's no more than 1% non-glass contaminants in the blended mix. And particle size is also pretty critical to the process. We want to have a predictable and controlled size of the particles. And this is a very fine powder. It's not gritty. It's not like a sand. It's more like a talc. So that powder is pulled through the pipe into this mixer and blended. We'll go downstairs next, where we'll talk about how the powder is distributed onto the kiln and heated through the tunnel.
Filmed that as we started walking down the stairs, the fire marshal showed up, and unbeknownst to us, was testing the fire alarms. So we threaded the needle on that one about as well as anyone can. So now I'm going to reshare.
You didn't record the fire alarms?
I do have a video of it. You can see it. All right. Now I will hand it off to Alexandra, who is our resident construction expert.
Hi, I'm Alexandra, VP of Sales and Marketing. Like Tor explained, I have a background in construction management as well as sustainability studies minor from UNC Chapel Hill. So what I'll do briefly is kind of walk through some case studies that, to Tor's point earlier, shows the range of application for the product. What we're looking at here is a residential build in Connecticut that we did last summer. It is a passive home. So as you can see, good amount of our foam glass aggregate backfill there. Likewise, a good amount of piping that's been stubbed up. I believe it's a mix of plumbing and electrical components. So, in terms of high performance, this particular home went to R20, but likewise, a lot of the kind of considerations that they had for appliance performance and then whatnot, the kind of our operational aspects of the interior of the home, we were able to kind of ensure that they could achieve all that they're looking for without kind of making any, constellations, if you will. So I think this project was really great in that it showed kind of the level of performance that you can achieve on a residential site. And we'll go to the next slide where we show a little bit of the element of speed that you're able to achieve with foam glass aggregate. So on the left here, this is another residential passive house build in San Luis Obispo, California. Of note that we received from the install team is that they were actually able to install quicker than they would with regular EPS or XPS board and gravel, notably due to how lightweight it was. So two-person crew can pretty much spread by hand, like Tor said, with a decent rake, the amount of the space. And I believe this is about a 2,000 square foot install. And then, one person with a vibratory plate can install. I believe it took them 2 days from the time the product arrived to the time that kind of final patch was compacted with that 1.3 ratio we referenced earlier. And then on the right, there's an install from Middlesex, Vermont, kind of in our backyard here, another passive home that we did. Again, you can see kind of the extensive stub up that they did. So I believe on this one, they kind of broke it out into a couple days. So they got a first layer going, call it about 4 inches or so, and laid their piping and stubbed up about, you can see 2 or 3 feet, and then did that final layer there. So that was another speedy delivery, and it's not in these pictures, but the bags that we provide were pretty much all lined up along the exterior of the home there. So it was a very tightly contained site. So your access to material that you get with the bags also helps, to Tor's point about coordination. There's not much staging that's involved. It's pretty simple backfill and compaction. The next case study that we're going to show, I think, shows the versatility of the product. As Tor mentioned, we do have green roof applications. This is one of our kind of higher profile jobs in McLean, Virginia, at the Tyson, the Capital One headquarters. So, as you can imagine with the green roof, there are a lot of weight and design constraints. But when you have, customers that want versatility and performance in their design, the foam glass aggregate is a great product for that. So they used our product under the base of, you can see the sidewalk areas, but there's also vegetation as well that they were able to use. The customer actually ended up liking the product so much that they expanded on the green roof, and they built a mini golf set. So again, a lot of versatility in the product. It can be mounted up to 45 degrees. So I think it's quite a challenging mini golf course that they have there. But there's an incredible amount of elements to the design. And we really enjoy kind of working with designers to that end and trying to push, the architectural elements as much as we can.
Now, I'll just add, with the case study on the left, the people who did this build in San Luis Obispo documented the entire process. And if you look up Bishop Passive House on YouTube, you can find they did 10 or 12 different videos that detail all the components that they used in the build, and there's some pretty incredible videos that they put together. So that said, we're going to now do another Texas two-step and get ourselves over to part 2 of the facility tour.
It was a cliffhanger.
I know it was. So it ends, the last minute or so we have to cut out because the sound got a little funky. So it might seem like it ends a little bit abruptly, but it's just because we're sparing everyone's ears.
All right, so now we've come down off of the mixing dose platform. We're standing in front of the kiln. So as we talked about from up top, the glass powder is blended with our foaming agent just above us in a mixer. And it comes down into this receiving hopper, and then it's distributed across this belt. So the roller that you see here with the brushes on it, the purpose of that is to evenly distribute the powder in a uniform cake across the width of this belt. We put it down at about 2 centimeters in thickness, and when it comes out, it's expanded to 8 centimeters. So it's about a 4 times increase in thickness. The other thing to point out here is that so the belt that's running through this thing is a continuous belt all the way through the furnace. It's a chain link belt made of steel, and it actually goes down into a pit here. Because what happens during the process that this belt is, of course, under tension and high temperature. So over time, the belt starts to stretch. And as it stretches, it gets longer. This pit that we built into the floor is designed to actually take up the slack that occurs as it stretches. That buys us more time between having to service the belt. When it gets too long, you can actually stop the machine and take links out, but you want to avoid doing that. To make that as infrequent a process as possible. So that's why we built this deep pit, to give us that more time between belt services. So we'll walk down to the furnace and explain what's going on here. The furnace is really the heart of the operation. This is a thermal process. What happens in the process is your glass powder, which is, as we mentioned before, very small particulates. As the heat starts to work the powder, the individual particles sinter, which means they start to physically adhere together. So the glass is starting to soften, but it's not fully molten. And so what's going on then is as the particles are starting to come together, voids exist between those particles, and the foaming agent generates gases that fill the voids between the particles and generates foam. And so, as I mentioned, it goes from 2 centimeters to 8 centimeters. We're doing that with a very controlled thermal process. So you start at the beginning of the kiln here with a set point at an initial temperature, and you gradually climb through each of these subsequent modules. So as you're going through the first 4 to 5 modules, you're achieving your maximum temperature, and this is where the foaming starts to occur. The process gets to upwards of 1500 degrees Fahrenheit, so it's very hot. Once we've achieved foam, you start to bring the temperature down gradually. And it ramps down to the end of the belt, or the end of the furnace, which we're getting up to in a second. What we're passing here, by the way, above are 2 stacks. So one to exhaust fairly minimal process gases, and the other at the end here is waste air. So the other part of the process, and part of the key in controlling the thermal temperature, the thermal ramp, is airflow. And so we bring air into the back that then loops back around and it exits through this last stack. One key thing to point out about our operation is that we are heating the furnaces with electricity. So we're committed to a very low carbon footprint, low embodied carbon, renewable energy. The majority of the industry is using natural gas to heat their furnaces. We're committed to electric, so this first line is electric, and all subsequent lines are currently planned to be electric. So now looking at the furnace from the end, the product will come out this point, it's now foamed and approximately 8 centimeters thick. It jumps from this belt to this belt, and the whole purpose of this last stretch of the operation is cooling. So this is referred to as the cooling table. And what's happening here is the foam glass comes out as a continuous slab. And as it cools, you generate thermal stresses. The room is obviously at ambient temperature and the foam glass comes out hot. So you start to get stress as the material cools and it cracks. It starts with, bigger pieces, and as it continues to crack and gets to the end of the line, it's cracked down into chunks, maybe the size of a large grapefruit or small melon. So we don't do any unique sizing of the product. It just gets to the state that we sell it in, which is roughly 2 to 4 inches on average. It gets to that state just through this thermal cooling, through thermal stresses as it cools, and through the handling that we do from the end of the line into our storage area and into trucks. And so the last part of our installation that we really need to handle over the next few weeks is we'll create a penetration in the end wall here with another conveyor to take the material off of this belt and dump it outside. We will be constructing a concrete bunker that will house the material. It's continuously water falling off the end of this thing, and we will take it away in buckets and either load it directly into trucks or into our storage yard.
Where I have to cut us off. That's where the sound gets a little wonky. So we'll spare you. We're a little bootstrapped at this point still, but we promise once the facility's actually up and running, we will have real lapel mics and we'll be able to put together something with actual product moving along the belt. So now, Rob, since you've been so patient, you must be like a racehorse ready to run.
Can you believe how quiet it's been?
That's a little surprising. All right, so now I'll hand it over to CEO Rob Conboy. Wait for it. There you go.
Thank you so much, Tor. So a lot of you know that the history of foam glass starts with recycled material, and that's what really drew me to this product, being able to take a material that had little or no value and turn it into a highly valuable building material. So starting with recycled glass, it was clear that there were other important opportunities to layer on top of what the Europeans have been doing for about 20 years and to make our own mark on what foam glass is going to be for the future. And then huge part of that, and hearing Alicia articulate all of the ways that we are living our commitment around social justice, is amazing as an entrepreneur wanting to integrate and create a culture that values those things is one thing, but having a team that can actually bring that to life and embrace it and see the value in that is just quite frankly really exciting, and it's going to be at the core of who and what we are as we move forward. So again, obviously we're very excited about producing the product, but the way that we produce it is as important and critical for us to make it our own and do it in a way that is meaningful for us and for the planet. Which then leads to the fact that, as Ken mentioned, the low embodied carbon component of the material, it already has comparatively a very low embodied carbon to other building materials. I guess that's on the next slide. But what we have done was electrified the process. So as Ken mentioned, most foam glass plants are gas fired and burning fossil fuels. But with as we know, the imperative around fixing our global carbon problem, the electrification of manufacturing is a critical component of that. It was 2019 when we announced with Zach at Passive House Canada our commitment around electrifying our process and moving towards 100% renewable energy to run our plant. From day one, thanks to Green Mountain Power, the electrons provided to our plant will be carbon free. And we are working with a partnership with Encore Renewables and Green Mountain Power to make good on the promise of 100% renewable energy supplying our plant. So that is a big milestone to come, but it is in the works, and we're very excited to be using 100% renewable in the not so distant future. The next slide. And again, we've come a long way since that, conference in Darmstadt where Flores from 475 showed me a piece of foam glass and said, we should make this in North America. And we've evolved to a commitment around low embodied carbon building materials, and knowing that we can't achieve our common goals without a commitment to equity and social justice. We know that thanks to Skanska and Microsoft and folks at EC3, that the awareness around the embodied carbon in building materials is coming to the forefront very, very quickly. And we're just excited to be part of that movement and being able to supply a product that will help folks meet their low embodied carbon goals.
So that's all we have for the time being. We're really excited for all this. I think you can tell every one of us has a lot of passion for a lot of this. Over in the other room, we have Jen, our business administrator, and Tim, who's our new project engineer, who are also integral to all that we're doing here. And so with that said, Zach, if we have any questions, it looks like there's been a little bit of activity in the chat.
Yeah, just a little activity. There are tons of questions, lots of great questions. So if you're ready, we can dive into those. So the first one comes from, and let's make sure that Evan is here, from Evan Grulich. Okay, great. Evan, can you ask your question?
Sure. Hey, y'all. I'm an architect in Baltimore. It's two questions. The first one is if you've done a similar cost comparison for foundation wall details for the foam board versus EPS or XPS. And then the other one's just a general curiosity about what the foaming agent is, what that material is. Thanks.
You want to take the
Yeah,
costing comparison?
Sure. I don't think we've done a cost comparison like similar to what you saw in the presentation for that particular application. But I do know anecdotally, I think that the big savings that you're going to achieve in that sort of approach is labor savings, right? So a lot of times those boards on the exterior have to be custom fit, or there might be some kind of tricky areas, but the free-flowing nature of the product and the kind of plate compaction, I think allows a lot of time savings. But Evan, if you have a particular design and question or specs, you can absolutely send them our way and we can talk more details. Likewise, I believe you asked a question about the foaming agent.
Yeah, so the manufacturing process in Europe falls into two camps, either what they call a dry process or a wet process. Both ways of manufacturing foam glass allow a pretty wide variety of compressive strengths and R values. We've chosen to use the wet process, which is utilizing glycerin to form the bubbles. If it's the dry process, it's calcium carbonate. But essentially, with changing the speed of the belt, the particle size, the mixture, you can achieve a pretty wide variety of products. We're starting with replicating the product that we are currently importing from Glidepore, which achieves that 1.7 per inch. And in the future, we hope to do our own tweaks on the formulation.
Great, thank you. Thanks, Evan. Did that answer your questions?
Definitely. Thank you.
Okay, fantastic. All right, so next up is Kath Monstring.
Hi, I don't know if you can hear me.
Yes.
I'm curious, it seems like it would take an exorbitant amount of glass to fulfill your needs in this area. And I'm wondering where you're going to get the glass. Is it imported or where does it come from?
Yeah, thanks for the question. Yeah, we're fortunate here in Vermont. There's about 15,000 tons of glass produced per year, and that is just about what we need for the plant. So there's a nice ratio of what we need. There also is a glut of glass currently in Vermont, and we have partners in states bordering us that have glass as well. So we're fortunate to have a steady supply of glass. Good, clean glass. Great question.
Thanks, Kath. Okay, next up is Patricia Smith.
Oh, hi, I didn't know I was going to ask a question.
Oh, do you, so I have, your question was about the inclusive values and a question about actively recruiting.
Oh yeah, actively recruiting people with disabilities. I just find that that is a group that people leave out of the laundry list of people who are discriminated against. And I just wanted to remind you to add that to the list.
Will do.
Absolutely.
Thank you, Patricia.
Thank you.
Fantastic. Hans, you're up next.
Hey, thanks for the tour. My question was about the codes. How acceptable is this product to be replacing gravel in general?
We really haven't run into any issue with code enforcement because it is seen as an aggregate. So if there's any questions regarding the codes, as long as you know, they review the compressive strength, we have ASTM testing, code really hasn't been an issue at all.
Cool. And then another question I had asked a bit later was about, and this is maybe a bit nitpicking, and you may have touched on this, but how much energy do we save using Glavel over, let's say, a 50-year cycle versus the energy that is put in? So it is about carbon, embodied carbon, but is there any numbers on that?
Yeah, so I've been really conservative about not making claims in that regard until we have the opportunity to hire somebody to do a proper LCA. What we know is anecdotally from our partner in Europe, we've got their EPD report that we're happy to share. But I'm just very careful as to making claims in terms of where we're going to land, other than to say, given the fact that it's, you know, zero carbon electrons feeding the plant, it's going to have a great story. I just, you know, I think it's kind of, we're just very cautious and just, we want to be authentic and transparent and not make claims that aren't substantiated. So we're just really careful about how we couch that.
Yeah. All right, thanks.
Yeah.
Thanks, Hans. Okay, next up is Trevor Harris.
Hi, I've been going over the idea of using Glavel in a house I'll build, and but I'm trying to imagine in my layman way the way that air would move in a foundation if I have 18 inches of Glavel through itself, and so what the detriment to the R value is as you know, warmth from the floor goes down and then comes back. So if there's any circulation, so it's my questions are, you know, how much breakup is there? How much infill is there from broken up Glavel in the compaction process so that it's filling those holes, or if there's some other sort of fill that you can use that would increase the insulation value in that process, and also you know, what the possibilities might be to using Glavel in a wall assembly, sort of like you might use aerogel. And then I had another question down the road, and it was, what was it? Because I want to get them all out now.
Well, Trevor, why don't we start with this first one, and then we can, when we do the next one. Yeah.
So Basically, once you've compacted the product a third, you're eliminating the voids between the product. That said, we have had a project where they were doing an active measure radon, where they were creating a pooling of air through the product, and we worked with Glavel to kind of calculate what would the effect of having that air being flown through the product, what would the detriment be to the R value? And what we settled on was essentially, we published if the product is wet, where you have water in between that void, or dry, the R value is 1.7 when it's dry and 1.3 when it's wet. So to compensate for that active measure, we did some calculations in terms of where the airflow might be, and then offset by 1.3 versus the 1.7.
Yeah, and I think what Rob is trying to articulate with that kind of localized approach is that it's not like a kind of expansive impact. It is kind of local to where you have the kind of origin of that active radon measure, that active kind of air draft, if you will.
Yeah. So barring having an active measure radon system, or if you have a high water table where you think some portion of the foam glass is going to be underwater, we can help with the building design in terms of how do we factor in those two conditions to get you the targeted R value over time. I will say, again, kind of anecdotally, what we've seen with the alternative of rigid foam board over time, if it gets wet or if there's critters that have eaten through it, you're diminishing the performance of that rigid foam board over time. And Glavel just doesn't have those issues over time. You will maintain that R value because it's not going to degrade due to moisture and or insects and rodents.
And in terms of a wall assembly or a detail that you could do a slab to slab with having Glavel as a sub base, and then something else, not EPS or XPS as the floor, what would you do?
Yeah, so we do have details for that. Instead of the kind of concrete slab, you can do wood. So that's kind of the approach that we've seen utilized over in Germany. So there is precedence to that end, using wood. And then likewise, there is a similar formulation for the aggregate. It basically, if you recall in the video, there's a cooling table and then it kind of rolls off from there. The difference is, one of the differences is that it anneals over time into a kind of static, I believe it's like 2 inches thick. So you can also use that board and then maybe put wood on top of it, or you could just use the aggregate, and we can send you those details.
Yeah. And we will have a board version of foam glass available. Our partner in Europe, Glavel, does sell a board version, but container prices right now are just insane. So until they become more rational, so stay tuned on that.
Thanks so much.
Yep.
Thank you, Trevor. Okay, so next up is Michal Bartko.
Thank you. Great presentation. I'm glad that foam glass is finally in North America. Well, my question was already answered when you were answering Hans's second question about the EPDs and embodied carbon. So, but again, I would be definitely happy if you could send the EPD from the Europe that you mentioned that you have.
Yeah, absolutely.
And I'm sure that you are going to make your own EPD when the facility is operational. When would you expect this to happen? I mean, question like, would you have EPD within 1 year, or is it a question of a couple of years?
Yeah, I think that the current lead times that we're receiving and we're still kind of sourcing out which consultancy we'll use, it's about that 6 to 9 month time. And because the product doesn't have much in the way of input, as you all saw, I do think we'll be able to be closer to that 6 month range. So, hopefully it's something that we'll have certainly by this time next year is the plan.
We'll be waiting impatiently for that. Thank you.
Yeah.
Thanks.
Thanks, Michelle. All right, next up is Tamara Melnick. Tamara.
Hi, sorry. I guess I was just curious. My sister works as the head of trash collecting in Knoxville, and so we're always talking about recycling and where to send things. So I was wondering, as you scale and grow, how you're gonna get your recycled glass once all the supplies in Vermont dry up.
Yeah, no, it's a great question. And as we look at other markets where we want to expand into, it is critical that we have, first and foremost, a partnership with the recyclers. I know down in kind of Arkansas and near Memphis, there's groups that have been looking at foam glass, and we're really supportive of foam glass expanding, no pun intended, far and wide. We think the acceptance of the product comes with more suppliers, all of which will have their own kind of take on the product. So we welcome the more players to the foam glass community, because we think that just makes the product that much stronger.
Thanks for all your work. I think it's an amazing product, and I really appreciate your mission.
Thank you.
Thanks, Tamara. Okay, so let's see. Next up is Ingrid Green, and I think Ingrid had to leave, so I'm going to ask her question for her. She said one of the daunting elements of starting an innovative company is the funding intense requirement of creating a facility like this one. So her question is, how did the founders deal with that, and where did the funding for this beautiful facility come from?
When I started this, I had long, dark hair. I've been around a lot of startups, so I think the process of fundraising wasn't new to me. And we've got a really great ecosystem here in Vermont of angel investors and support in that regard. So that was part of the reason why we located our first plant up here in Vermont, was that kind of support that we were able to achieve in the early stages, and having the right partners from our landlord and others has just been really amazing. So, and shout out to, I see Tim's on the call, so definitely need to follow up with Tim Wayland.
Tim Wayland, yes, Tim is my former boss.
I know.
So it's great to see him on the call. Hi, Tim.
Hey, everybody. Can you hear me okay?
Yes.
I was late.
No worries. We have
Hey,
we have a recording for you, Tim, so you'll be good.
Okay, sounds good. Rob, I just sent I downloaded the civil part, and I sent we should connect offline.
Great. Thank you, Tim.
Invested in volume and timing.
Sounds good.
Right.
Awesome. Okay, so next up is Jane Sanders. I think, let's see, make sure that Jane is still here.
Oh, hi, I'm still here.
Hi. Yeah,
hi,
hey,
everyone.
Jane.
Yeah, I put a bunch of questions in there. I'm trying to remember what the first few
Oh,
were.
yeah,
but,
sure. I can help you.
One thing I'm curious about is, could it be potentially in the future used as an aggregate in concrete?
I would say in early days, that was one of the first questions, was could you put it as an aggregate in concrete? And my first knee-jerk reaction was to not go there. Concrete is a whole other set of chemistry and has a lot going on in terms of adding an aggregate. And quite frankly, there were just so many proven applications, both civil and in the built environment, with the product that I just didn't see a need to complicate our lives by putting it in aggregate. That said, there absolutely are cement guys out there that are thinking along those lines, but it's just not something that we're necessarily focusing on.
Okay, great. And then my other one was, I see that the plant is powered by electric instead of natural gas, but what is the source of your electricity? And have you looked into, installing solar panels on site to have some of that be local?
Yeah, so as I mentioned, Green Mountain Power is claiming 100% carbon-free electrons. So it is green, pink, and blue electrons. So it does have some nuclear in the mix and some hydro. What we're doing is sourcing separately, contractually, a massive solar array to supply energy to the plant to make up the difference from what Green Mountain Power has in their supply of renewables and the renewables that we need to make up the difference. So it's in the works.
Okay, thanks. Yeah, and my last question was the embodied carbon issue, which you've already discussed. So thank you.
Great, thank you, Jane. Okay, next up we have Nathaniel Weiss.
Hi, my question was answered in the chat and in the post-presentation discussion. I was just curious if a foam glass board product was forthcoming, the feasibility of it.
Yeah, like we said, very similar to us importing the aggregate product before we got our plant up and running. We'll be importing the board product from our partner Glavel once the cost of containers make it feasible. I mean, we could do it today, but nobody would buy it at the price that it would cost to bring in the board. So we're really just waiting for a bit more rational pricing on the logistics side, but definitely stay tuned. We do have it on our website. You know, we have quoted it out. There are folks that you know, money was no object and they wanted to look at it. So, you know, we're welcome to have the conversation, but just know it will be pricey.
All right, great. Thank you, Nathaniel. Next up is Shannon Pendleton.
Thanks, Zach.
Thanks, Shannon.
Thanks for a wonderful presentation. It's a great product, great mission, really great people. My question is, do you know what the lead times will be when we can start to order? And also, how does it plug and play with the Passive House modeling packages out there and the certification process? Or do you anticipate, how do you anticipate that going?
Well, that's so embarrassing that I don't know how it plays into PHPP. And I should, as a certified Passive House consultant, I should know that. But I'm sure you could plug in the R values into that. And hopefully we'll be on the EC3 platform. And I believe PHPP now has a way of bringing in the embodied carbon into PHPP, or at least I think that was in the works. So that would be one way to get those numbers. But it's definitely a thing that we can add on our side to make sure that for the Passive House folks, it's you know, you have so many numbers you have to put into PHPP, we might as well make that one easy. And then in terms of the lead time.
Yeah, in terms of lead time, we should have sellable product in February. So we're certainly taking orders now. Likewise, as I'm sure everyone here knows, kind of the backlog that we saw from the early days of the COVID disruptions are easing up. So we are seeing a bit of an increase in demand. So the earlier and the more frequent coordination, the better. But we're certainly issuing out and signing conditional POs if we kind of have a firm project pipeline. But so I would say, yeah, that's kind of what we're looking at. And then in terms of, you know, from the time that an order is confirmed to delivery, generally figure, you know, 2 to 3 weeks.
Great, thank you so much.
Thanks, Shannon. And Steve Mann in Berkeley says that it plays fine with PHPP, just to put that out there. And Dale follows up with what about WUFI passive? So maybe we still have some follow up to do for folks to okay, so next up is Ravi Arps. Make sure Ravi's still here.
Greetings. Sorry for the backlighting. Thank you again for this presentation. Fascinating for a variety of reasons. I'm the CEO of a builder, a new builder based in New York City. And in all of the passive things that we look at, one of the questions that we have is, how do you see these types of products, and this one in particular, being applied currently, or similar products being applied currently to urban environments, where you're doing a lot of retrofits, where you have issues with landmark and all the other things, fun stuff that comes with being in dense urban environments. would love to learn if there are any best practices or ongoing projects that we might look at as a model. But thank you guys for your time and insights.
Yeah. You want to?
Yeah, I think, one of the kind of constraints that you might find in kind of urban construction sites is space, right? So to that end, I think that the bags play pretty well. They kind of sit up on their own, and typically with the way that we deliver, it's either going to be a flatbed or a 40-foot dry van. So not a lot of restrictions in terms of what street access looks like, and the unloading is pretty quick. I would say, if it's an existing structure, and let's say you're going sub-slab, kind of being strategic with your stockpiles is going to go a long way, and planning out access to bring the bags or maybe some sort of conveyor system to make sure that the aggregate kind of flows into that backfill space. Likewise, paying attention to your lift levels that you do. So it might make sense to maybe do 6-inch lifts or 4-inch lifts as you go along, just to kind of alleviate that sort of footprint of the site. But if there was a specific constraint that you had in mind, we could certainly speak more to it. But that kind of question evokes coordination concerns. But I think that's kind of all that we've seen. And again, I think the bags are a good kind of strategic advantage. You don't have to have a pile of aggregate on the sidewalk or in the street or what have you. So I'd say that's one of the ways, but open to kind of anything else that pops up.
And we're hopeful to announce maybe by the end of the year, definitely by January, a logistics partner, especially just servicing the 5 boroughs. I mean, post-COVID, you know what the streets are like and how difficult it is, and freeways being shut down there and getting product in. So we're really excited and cautiously optimistic that we have a great logistics partner that knows how to deal with all those constraints day in and day out, and will help coordinate on site to deal with and mitigate the issues that Alexandra just spoke of.
Thank you. That sounds great.
Yeah.
Fantastic. Okay, so next up is Paul Harrington.
Hi, Rob. I met you a couple of years ago in Burlington, and you gave me 2 sample bags of Glavel, and ever since I've been waiting anxiously for the factory to start up. So I'm just want to say congratulations on it looks like a great facility, and I'm looking very much forward to being one of your first customers in the Boston area in hopefully in February or March of 2022.
That sounds great. And we can't wait to have you back up here.
Thank you.
All right, we have a number of people that I've missed somehow. So we have more, we definitely have a list of questions coming. So let's see, next up is Michael Davis.
Hi, apologies if I missed this at the top, I came in late. But I was just curious as to what your expansion plans are specific to the West Coast and just across the US and North America. Thanks.
Yeah, we're looking at lots of different options, and clearly the West Coast is really important. So I guess not to be cagey, but stay tuned on that front. We know that we need to be out there sooner rather than later, and we hope to be announcing some news on that front.
Just an exciting product and looking forward to getting to utilize it. So thank you.
And I should say, Alexander is working tirelessly to deliver product to the West Coast incredibly affordably with different options. So if you have projects, don't wait to reach out to us, because she really is working on hammering down the costs for bringing product into the West Coast.
That's great to know, and I plan on pushing this out to a lot of our consultants, both civil and structural, for review. Thanks.
Wonderful.
Great, thank you, Michael. All right, Jason, you've got some questions, I think.
I do. Can you guys hear me all right?
Yeah.
All right, perfect. Will the glass source be considered pre or post-industrial or post-consumer or a mix of both?
We'll just be using post-consumer, so recycled glass from curbside recycling.
Okay. The one question has to do with another. So on the plant tour, the fella said that it was coming out as is. There's no purposefully manufactured particle size. Would there be any plans to create particle sizes, possibly 3/8 inch or less?
I'm cringing. Part of my cringing is that there was a couple of foam glass producers that are currently no longer in business that were doing sizing and crushing and specific sizing. And part of the problem is when you go to specific sizes, you just lose a lot of product. Are there other ways that we're thinking about fixing that problem? Alexander and Ken have been noodling that. I don't think it's going to be something that is a high priority to sell by size, but there's lots of reasons to do it. Happy to offline if you want to shoot me an email, just rob@glavel.com to chat about it further.
Okay. So one of the concerns that was raised with the group that I'm part of is compressive strength. If you were able to get to this size of 3/8 inch or less, I'd be worried about compressive strength, specifically walking on it. It just crushing underneath the weight of a person. Do you feel that would be an issue or no? I mean, I know it's used you're using it in housing and whatnot, and all the example that you gave on the presentation, but as an aggregate surface to walk on, would there be an issue? Would you foresee an issue of it just crumbling under your feet?
No, I don't think so. Especially kind of when compacted, and then we do recommend a minimum of 6 inches compacted. So I don't see that as much of an issue with the kind of resizing that you're speaking of.
I'm thinking of it in a different application altogether. So I mean, I can go into it later with you guys. So the last question I had is just mostly the design, the plant tour itself. You guys have that glass coming out of the heater, 1,500 degrees or so. That space is going to get monstrously hot, and I see a fridge about 6 feet from the end of that. I'd hate to be the guys putting food in there.
Yeah.
You're very confident that it'll be cooled off by the time it gets to the end.
Yeah, good eye. So the fridge is only temporarily located while we're doing the installation, so that'll move to a break room.
Okay.
But your observation about the heat generated in that cooling area is a good one. So we will as we complete the facilities fit up, and eventually, and I guess we should have pointed out in the video that what you see there is the first of 2 lines. So there's a lot of open space in that building. We have plans to fill that space in the future. That'll stay tuned on that one as well. But we also have plans for how do we want to manage that. So that in the summertime the factory is comfortable. In the wintertime we utilize that heat that we're generating that in that last section of the.
In the wintertime it should have no trouble, but the summer, whew,
Yeah. Oh yeah.
Hot place. All right, I'm good. Thank you.
Thank you, Jason.
Thanks, Jason. Great. So our last question is from Jeffrey Roden. And if anybody else has another question, or if I somehow inadvertently missed you, please just post it in the chat and we can catch it. Otherwise, we may be wrapping up after Jeff's question.
Thank you very much, Zach. Great product. I'm outside the Boston area. My question relates to the compaction. Can the product be over compacted, or is it just, and is it breaking up the product more when you compact it? And how does that affect the R values and all?
So I guess the short answer is, yeah, I mean, if you kept on running the compactor over, you would continue to eliminate the voids and break the product down further. One of the things that we've done is created a road show, if you will, that allows for installers to play with the product before they actually install it, so they get a sense of what the compaction is. It's not a quick trigger, like all of a sudden it turns to dust. It's a process. So using very standard leveling tools, so you know what your target level is for that compaction,
you really shouldn't have an issue of all of a sudden you've over compacted the product. In terms of the effect on the R value, I haven't had that question yet, and it's not clear to me that, you know, compacting it, if you went just, you know, greater than that 1/3, that you would significantly diminish the R value. So my inclination is that it wouldn't diminish the R value, but I'd want to just verify that with folks that have been doing this for 25 years.
Again, it's good to hear that you got your second and third lines in the planning phases. I think you're going to need them pretty quickly.
Yeah.
Thanks, Jeff. We have another question from this one from Dale Holst.
Just a quick question. If your sub slab, you've compacted it, any special recommendations for the membrane that would go over it before you pour your floor?
Yeah, so we do recommend, you know, you want to isolate the foam glass aggregate. So generally, kind of putting a simple geotextile, think like a Merafi 140N along the sides that separate between the dirt and the foam glass. You can kind of lap that over the top layer. And then you will, you know, you kind of do like a vapor barrier, think like Stego on top, and then you can kind of pour your concrete from there. So no kind of special material. These are all, you know, kind of the fabrics that we all know and love and can get our hands on pretty easily. Wonderful.
Great. Thank you, Dale. Well, that is it for the questions. You guys, this was just so fantastic. Glavel, really exciting work. I think you can see from the turnout and the curiosity about what's happening, and that everyone's been very eager to see this development come to fruition. And so it's super exciting that's the case. And I think we had lots of great questions and answers. We're now, an hour and 15 minutes into this fantastic tour and component spotlight. So a big thank you to you all, to Rob, to Ken, to Alexandra, to Tor, and to Alicia. And thank you to Glavel for your support of Passive House Accelerator as a founding sponsor. Thank you everyone in the audience for joining us for this event. And we'll see you next time for more great Passive House information. So have a great day, and we'll talk soon.
Thank you.
Thanks, everyone.
Take care.